My name is Samuel Chung from the Salt Lake City, Utah, at the University of Utah. We will talk about smart curtain wall. And as you know, curtain wall is a very important component of the high-rise, low-rise, every buildings. So curtain wall may not necessarily of any load-carrying component. However, it should self-stand, and it should take horizontal loads such as wind or earthquake. And also, as you know, the cost of curtain wall is very good portion of overall construction cost or material cost. Recently, the technology is developed, and we have high-strength laminated glasswork or the metal panels or masonry type of walls. So now, today, we have 5 speakers from all different trades will show the what they got to show us. So let's let's listen to what they bring us. Okay, first speaker will be Mr. Stefan Kratzmeir. It's a German name, I believe, from Germany.
Each speaker has 25 minutes for their presentation, and I will ring the bell after spending 20 minutes to let you know. You just need to wrap up.
Thank you, Mr. Chairman. First of all, I'll shortly introduce myself. My name is Stefan Kratzmeir. Actually, because it was changed very short notice, few days before, my presentation has nothing so much to do with the topic of the session. So actually, it's more a bit about fire protection, but I hope it's interesting for you as well. I'm the head of the R&D department of the German company Fogtech, fire protection manufacturer. And I will try to introduce a little bit how water mist in particular can be used for tall buildings. Actually, a few words about the company. As it was already mentioned, it's a German company with head office in Cologne, but offices worldwide and also partners worldwide, also here in South Korea, which are dealing then with the local let's say the local stuff. We are not doing water mist systems, purely water mist system, not only for building, but for many other applications, just to mention that it's not just a small backyard company. Now come a little bit more to the topic, water mist. Water mist, I think you all know sprinkler systems, and just look to the ceiling, you should see a sprinkler system, at least I hope so. And most of the tall buildings in the world, there are sprinkler system, and that's good. But it's not the only technology that can be used. What is water mist? Water mist is well known as very fine droplets. The water is split up because we need, or we want to create, a much larger reaction surface. So if you have a sprinkler droplet, it's like the rain outside. You have a very big, large droplet. It falls down, it cools, it's extinguished the fire for sure. But if you decrease the droplet size, then you have a much larger surface, which will help to get much better cooling and some more effects. It's not a new technology, by the way. It's known since decades. It's used since decades. But it's now merging into, let's say, the building industry, I would say, since 10, 15 years. and more and more spreading. As I said, the cooling effect, because you have a very large surface, you can absorb the energy of the fire, and that's the major cooling effect of water, pure water. The good thing is, and these typical curves you only see with water mist, for example, this sharp reduction of the temperature, but that's what you want to get. You will not see it with a sprinkler, you will not see it with any other gas systems or whatever, and even if you have very high temperatures, you will reduce them immediately after you activate your system, because the water absorbs the energy by vaporizing, and that's what we do with the large reaction surface. We vaporize the water. A further good thing is that we can protect the whole surrounding also from the radiant heat. There's another effect, it's called the inerting effect or oxygen depletion effect, and that makes it much more effective than any other fire extinguishing agent ever, except halon, by the way, but it's banned. Because we are vaporizing the water, we are depleting the oxygen. It's not dangerous for people. You can still survive it because it's just in the flame zone, just there where it's really hot. You're reducing the concentration of the oxygen to, let's say, 16-17%. That's absolutely harmless for people. But both effects together are, let's say, combining themselves and increasing the efficiency of the system. And you can even extinguish fire of gasoline. You can extinguish deep fat fryers. You can extinguish large diesel pool fires without any problem. So why should you use water mist and not sprinkler? As I said, sprinkler is fine, sprinkler is good. It's well known since 100 years, and in my opinion, every building or every larger building should have a sprinkler or an equivalent system, no question at all. But what is the main difference? The difference is the amount of water we use with water mist. Normally it can be said as a rule of thumb, it's around 20% of the water compared to a sprinkler system, having exactly the same effect. The second thing is we are using high pressure, which means that we are operating pressure is around 120 bars down to 50 bars, so we can allow a much higher pressure loss in the pipes. That's just purely mechanics and just purely calculation, but that's very important because when you design the pipe network for your building, which then shows you, if you use a sprinkler system, you have pipes which you have to hide, which needs to block your normal installations in the buildings between 40 and 200 millimeter. That's really a lot. And we all know it's very difficult to place them, and they're not looking very, very nice. If you use a water mist pipe, it's a purely stainless steel pipe. It's a high pressure pipe, but it's much smaller. The normal branch pipe in a building is around 12 millimeter. You will hardly see it. And even the main risers in large buildings are not more than 60 millimeters. The next good thing is you just need only one pump station. Just on the ground, there where you have water, you have power there, it's no problem. It's not necessary to elevate everything in upper floors. You can just put them on the ground. Because of the pressure loss you can allow, because you have a higher operating pressure, you can pump the water even to very high levels without having too much pressure loss. And of course, the major effect is the amount of water. And that's a typical picture you will have when you activate a sprinkler system. Of course, it's effective. It's called the oceanic extinguishing effect. You put just so much water in the building that everything is out, and your building is really heavily damaged. If you have larger buildings, you even get a problem with the statics because it's huge amount of water. Normally it's at least, and that's really the minimum figure, it's at least 5 liters per square meter per minute. And then you can just roughly calculate how much water you will pump into floors. If you use water mist, you have just, as I said, 20% of the amount of water. The next good thing is sprinklers are using black steel pipe. And if you saw an activation of a sprinkler system after several years standby, you just have a brown ugly, dirty water, which also destroys everything inside the rooms. Because water mist is always using stainless steel pipes, your water is clean, even after years. The good or bad thing, sprinkler, as I said, experience 100 years, no problem at all, they are effective. But for water mist, we always have to prove our effectiveness by using full-scale fire test, which means, well, we have to build rooms like this, conference room, or just to show you one example from a typical approval test, it's an office. You see there's paper files, plastic files, you're simulating walls. Of course, you do some kind of worst-case assumption that the walls are made of wood. These sofas are polyurethane, non-fire retardant. For sure, in a real building, you will never find this, but you really want to push a little bit the system and check it. And in this case, it's very easy. You compare the effect of a sprinkler system. So you just build in a sprinkler system in this test hall, like a standardized system, approved system. And then you have to show that the water mist system is at least as good as your sprinkler system. Very simple. And hardly anybody knows. This picture, by the way, is, it's as I said, from a full-scale fire test, no sprinkler and no water mist nozzle. With these glass bulbs, they will not activate with this small fire. You will maybe say it's a big fire, it's a small fire. So don't expect that a sprinkler system opens up too early. You know all these Hollywood movies when they come with a cigarette close to a sprinkler? Forget it. It's absolutely bullshit. So you need a real big fire to activate these kind of systems. Yeah. It's tested even up to 12 meters height. For example, here you see a test hall in France. It was even 15 meters. And there you see the water mist activated. It's really like mist, like let's say England fog or Britain fog or something like that. Bit more with more impulse for sure, and it's not so easy to design it, but just to give a rough estimation. There also you see some kind of sofa arrangement, so that's a fire test typically used for atrium areas, for big entrance halls and so on. There are also many more fire tests, as I said, for archives, for example. You're building whole archives full of everything, full of paper, even full of plastics. And then, of course, later on it's installed in such archives. Here, for example, you see the Czech, in Prague, Czech National Library, and the whole building, and also this big atrium area. It's not sprinklered anymore, it's completely protected with water mist because they want to avoid the water damage in case they have a fire. As I said, these systems are usually just sprinkler equivalent, so you can build them in as a typical sprinkler. You have no size restrictions, the demanding area are typically as a sprinkler systems. You can also, and let's come a little bit to the topic of the session, so I just included this because I saw this. You can also use them for other effects. For example, if you have big glass facades, and we had several projects already in the past where it was extremely costly to upgrade these glass facades for fire protection. So if you need, let's say, 30 minutes, 60 minutes, even 90 minutes protection of glass facades, it's getting really heavy, it's getting really costly. And there are two ways to minimize the costs. If you install a water mist system anyway in the building, you can either install from the outside, and that's a typical oven, a test oven, fire test oven, where you do the approval testing for a glass element. So the so-called, for example, with the ISO curve or several types of fire resistance curves. And there you see a curtain of water mist. And the combination of a weak, I call it weak, it's not really weak, but a weaker glass and the water mist curtain allows to get a much better rating for the glass, and of course reduce the glass weight, reduce the glass size, and reduce the costs of the glass extremely. This was another fire test, again a small test hall, a typical element of this building. Unfortunately, they just decided, it was for Russia, they just decided not to build the whole building. but they prepared already. And there, the water mist system was placed inside. There was a water mist system anyway planned to fight the fire, that's good, but a second row of nozzles just in front of the glass facade to protect the glass facade. And we did also some approval testing with a big fire load in the back of this room, large wood grips, and here you see the glass facade, and then the water mist system was just behind the facade. Also, this facade resisted for around 90 minutes without having any problem, and even with a standard glazing, no fire protection glazing at all. I just want to give you another example of a huge building which is completely, or at least a part is completely protected with water mist because for several reasons. It's the so-called Mekka Clock Tower, so maybe you have heard about it. That's really, it's a very impressive building, to be honest. The big king of Saudi Arabia decided that he wants to have a really huge building in his city, and just next the holy mosque in Mecca, and he wants to have the largest clock tower in the world. And as you see, it's quite similar to a well-known building in London, the Big Ben, and that was the existing building, and then decided to build this clock tower thing on the top of the building. And if you build something on an existing building, you can imagine weight is an enormous problem and space is an enormous problem. And so the overall, it's just some facts about the overall building. It's above 600 meters, that's really a lot. Just the clock itself, it's 5 times bigger than the clock in London, the original one. And it's a typical use for a high-rise or tall building, luxury hotel, other just office buildings is used. And it's just about to be completed, or I think it's almost ready now, and it will be opened, officially opened. It's this year. And the upper 210 meters are made of a very lightweight steel construction, and that was the problem. They were just not able to carry to carry the weight of a sprinkler system, especially when the sprinkler system is in standby. All the pipes are filled with water, and that's really heavy. So they were seeking for an alternative solution, and of course then they were coming to water mist because they're using smaller pipes. Smaller pipes means also less water, and so on and so on. Oh, thank you. The protection concept for this upper part of the building is, as I said, based on a wet, high-pressure water mist system. Wet means you have water all the time in your pipes. You have these small little glass bulb elements, and they will burst when you have reached a certain temperature. And to protect this clock, this huge clock, they used a so-called open system, which means you have an external fire protection system, and you just activate the full area. The system design is based on CEA 4001, OH4. Somebody who is involved in fire protection, that's well known to him. That's just the protection area and the type of risk. And for a typical operation time of 60 minutes. We also integrated some manual wall hydrants. They're also well known, and they're really liked by the fire brigade because they have not to carry the whole hoses and everything into the floors. And normally you're also using low pressure or connected to the sprinkler system hydrants, but you can also use them for water mist. And of course, sometimes there's a challenge, not only for water mist, it would be also a challenge for the sprinkler with the 12-meter height in the museum area. And therefore, we just conducted special tests in France just for this 12-meter height. As I said, the whole top area is protected with water mist. In addition, 83 so-called wall cabinets to let's say, add to the system and to avoid further damage, because normally most fires you can just easily extinguish manually in the starting phase, and just the sprinkler is the backup. For a water mist installation, it's quite a huge project with around 2,700 nozzles. Of course, it's not without any regulations. We are dealing with fire protection. We have to do a lot with regulations, I can tell you. Of course, water mist systems are not as old as sprinkler systems, and therefore there are not so many regulations. But, of course, there's NFPA regulations, there are FM approvals, sometimes not for all applications, but they're growing more and more. So this whole system is based on NFPA 715, which is the, let's say, the counterpart to NFPA, the sprinkler NFPA regulation, the SEN regulation, which is also the counterpart to the SEN regulations, or the EN norm for EN standard for sprinkler systems. We are also doing a lot with IMO. Why? The whole water mist is rising from the marine industry, and they have a lot of testing and approval regulations. And of course, we are still using it because we have a lack of rules in the other fields. And by the way, a ship cabin is similar than a hotel room, for example. And of course, we have well known also in the fire protection business FM Global, and VDS approvals. Just a few other projects where huge projects where water mist, where the whole buildings are protected. I think this building is also well known in at least in the world. It's the new Elbphilharmonie in Hamburg, also Germany. It will get a really landmark project, and I just were there 2-3 weeks ago, and it's looking similar to this nice picture, which is still an animation. And there the whole concert hall is protected with water mist, because with this height you cannot use any sprinkler anymore. Sprinkler is just pouring the water from the top to the bottom, and water mist can work 3-dimensional, so we are working from the ground. It's also used for old heritage buildings, for example. That's the City Hall of Madrid, where they have to upgrade the building. This we already seen. That's the Technical Library in Prague. We also have one in France, for example. And also new or nice buildings where you have to protect the glass or the steel beams, which you cannot use with a sprinkler system.
Much better.
Perfect timing. Thank you.
No, 5 more minutes.
If you have any more questions, then I think it's now the good time.
Thanks, Mr. Kratzmeir. Any question for Mr. Kratzmeir?
Anybody having questions here?
Hello. My question is it necessarily to use stainless steel pipes? Why? And also, what is the cost difference between a normal sprinkler system and this water mist system?
I would say for a standard office building, always use a sprinkler system. It's cheaper, because you cannot use the benefit of, let's say, the pressure loss. The stainless steel you need because of the high pressure. You cannot use black steel or standard steel with pressures above, let's say, 20-30 bars. It's impossible. As soon as the building gets bigger, the savings from the pipe sizes are really the key issue. And then for large buildings, really tall buildings, it's almost the same, the costs. Surprisingly, it sounds surprising, but it is the same.
Of the mist heads comparable to a conventional sprinkler system?
Usually the spacing, so the distance between the sprinkler heads or nozzles are slightly larger. For example, for a typical office area, I think the sprinkler head is 3.5 meters. It's very typical. And for water mist, it would be around 4.5 to 5 meters.
So the density would be an additional cost benefit in favor of a mist system?
Yes, but the head itself is slightly more expensive, so it's the cost benefit is again equal around.
So you save space in your risers as well? Your vertical risers could be smaller?
Absolutely, yeah. That's the main savings with the risers and the piping inside, let's say, the suspended ceiling or something like that. It's just much smaller.
Right. Thank you.
Welcome.
Any further questions? Okay, thank you very much.